Continuing with Advanced Math 3200, Unit 1, Chapter 3 on polynomial functions, we will discuss the remainder theorem. In this session, we will focus on describing the relationship between polynomial long division and synthetic division. We will divide polynomials by binomials of the form x minus a using long division or synthetic division. And we will explain the relationship between the remainder when a polynomial is divided by a binomial of the form x minus a and the value of the polynomial at x equals a. The remainder theorem states that if p of x is divided by x minus a, then p of a is equal to r. P of x represents the polynomial, x minus a represents the divisor, and r represents the remainder. In general, when the polynomial is divided by a divisor, it will equal the quotient q of x plus the remainder divided by the divisor. As well, we have the polynomial p of x is equal to the quotient q of x multiplied by x minus a, the divisor, plus r, the remainder. In the first example, we will use long division to find the quotient and the remainder. Then we will transfer the long division to synthetic division, which is a shortcut way of finding the quotient and the remainder when a polynomial is divided by a binomial divisor. First, we need to look at the terms. The terms are in descending powers of x, and there are no missing terms. To look at the divisor is of the form x minus a. So in this case here, the value of a is equal to 2. Setting up long division, we have x minus 2 will be divided into the polynomial x cubed minus 2x squared plus 7x minus 5. The first question we ask is x multiplied by what will equal x cubed? And the answer is x squared. X squared needs to be multiplied by both terms in the divisor. X squared times x is x cubed. X squared multiplied by a negative 2 is a negative 2x squared. Then we need to subtract all of it. And we have x cubed minus x cubed is 0. Then we have a minus 2x squared minus a minus 2x squared will again equal 0. We take down the 7x minus 5, and we repeat the process again. X multiplied by what equals 7x, and the answer is a plus 7. 7 needs to be multiplied by both terms in the divisor, so we have 7 times x is 7x, and 7 multiplied by a negative 2 is a negative 14. Again, we have to subtract all of it. We have 7x minus 7x is equal to 0, and a negative 5 minus a negative 14 becomes a minus 5 plus 14, which equals 9 as our remainder. Transferring the same information to synthetic division, you set up a box as follows. In front of the box, you record the value of a, which is 2 in this case. The numbers that go in the top row are the coefficients of your polynomial term. The coefficient of your cubic term is 1. The coefficient of your quadratic term is a negative 2. The coefficient of your linear term is a positive 7. And finally, your constant term is a minus 5. Doing the synthetic division, you add your first column, so 1 plus nothing is 1. You multiply the 1 by 2 to equal 2. When you add the second column, the sum is 0. You multiply 0 multiplied by 2 is 0. When you add the third column, the sum is 7. When you multiply that 7 times 2, the product is 14. And when you add the last column, the sum is 9. Note that the last term represents the remainder when using long division. To determine the quotient, in this case, the quotient is determined from this depressed equation, where 7 represents the constant term, 0 is the coefficient of the linear term, and 1 is the coefficient of your quadratic term. So we have 1x squared plus 0x plus 7 as the quotient. You do not need to put in 0x for your linear term, so we simply state that the quotient q of x is equal to x squared plus 7. This represents the same quotient that we did when we used long division. So synthetic division is a much shorter method of finding the quotient and the remainder when a polynomial is divided by a binomial. We can represent our answer as follows. We can say that the polynomial x cubed minus 2x squared plus 7x minus 5, when that polynomial is divided by x minus 2, the answer will equal the quotient x squared plus 7 plus the remainder 9 divided by x minus 2. That's a way that we can represent our final answer. Let's look at another example. Again, we will use long division and synthetic division to find the quotient and the remainder when the polynomial 2x to the 4 plus x squared minus 3 is divided by x plus 1. This time, notice that there is no cubic term. So as a result, we put in 0 as the coefficient of a cubic term, plus x squared, and notice that there's no linear term. So once again, we put in 0 as the coefficient of a linear term, minus 3. And the polynomial is divided by x plus 1. In this case, x minus a can be written as, or x plus 1 can be written as x minus a negative 1. Therefore, we determine the value of a to equal a negative 1 in this example. This is especially important for what you put in front of the box using synthetic division. Let's set up the long division. We have x plus 1 as our divisor. And that will be divided into our polynomial given by 2x to the 4 plus 0x cubed plus x squared plus 0x minus 3. We start off with x multiplied by what is 2x to the 4. And the answer is 2x cubed. Multiplying 2x cubed by both terms in the divisor, we have 2x to the 4 plus 2x cubed. The purpose for putting in the 0x cubed is so that we can line up our like terms. X cubes have to go under x cubes. When we subtract all of it, we have 2x to the 4 minus 2x to the 4, which equals 0. 0x cubed minus 2x cubed leaves us with a negative 2x cubed. Bring down the x squared and repeat the process again. X multiplied by what is a negative 2x cubed? That would be a negative 2x squared. Multiply that by both terms in the divisor, and we get a negative 2x cubed minus 2x squared. Again, we have to subtract all of it. a negative 2x cubed minus a negative 2x cubed will cancel to equal 0. X squared minus a minus 2x squared equals 3x squared. Bring down the 0x and repeat the process again. X times what is 3x squared? That would be a plus 3x. Multiply that by both terms in your divisor again, and we have 3x times x is 3x squared plus 3x, and we have to subtract all of it again. 3x squared minus 3x squared is 0. We have 0x minus 3x is a negative 3x, and bring down the minus 3. X multiplied by what equals a negative 3x, and that would be a negative 3. Multiply that by both terms in the divisor again, and you get negative 3x minus 3. When we subtract that, a negative 3x minus a minus 3x is 0, and a minus 3 minus a minus 3 is again 0. So in this case, we have 0 as our remainder. You have learned throughout this course that when the remainder is equal to 0, x plus 1 is considered to be a factor of this polynomial expression. Using synthetic division, we set up the chart as follows. In front of the box goes the value of a, which is a negative 1 in this case. Your numerical coefficients of each of the terms would be given by 2, 0 to represent your cubic term, 1 to represent your quadratic term, 0 to represent your linear term, and negative 3 to represent your constant term. When you add the first column, 2 plus nothing is 2. You multiply 2 by a negative 1, and you get negative 2. Adding the second column, the sum is a negative 2. Multiply negative 2 by negative 1, and the product equals 2. Adding the third column, the sum is 3. Multiply 3 by a negative 1, and the product is a negative 3. Adding the fourth column, the sum is a negative 3. Multiply negative 3 by negative 1, and the product is 3. When you add the last column, you get 0, which represents your remainder. The quotient in this case is given by this depressed equation. So you have a quotient which is equal to negative 3 represents your constant term, 3 is the coefficient of your linear term, negative 2 is the coefficient of your quadratic term, and 2 is the coefficient of your cubic term. So in this example, the quotient is given by 2x cubed minus 2x squared plus 3x minus 3, and the remainder is equal to 0. This is a multiple choice question that you could potentially be asked on a public exam. It says, what is the quotient when this cubic expression is divided by x minus 3? The fastest and most efficient way to answer this question is to use synthetic division. To determine the quotient, the value of a goes in front of the box. X minus 3 is of the form x minus a, so we can say here that a is equal to 3, which we put in front of the synthetic division box. The coefficients, 2 represents the coefficient of your cubic term, a negative 9 represents the coefficient of your quadratic term, but notice here that there is a linear term that's missing. So we need to put in 0 to represent the coefficient of the linear term, and 27 represents the constant term. Adding your first column, the sum is 2. 2 multiplied by 3 equals 6. The sum of your second column is a negative 3. Multiplying that by a positive 3, the product is a negative 9. The sum of the third column is a negative 9. When you multiply that by 3, the product is a negative 27, and the sum is equal to 0, which represents the remainder. Notice that the question is looking for the quotient. So in this case, the quotient is determined from this depressed equation. So you have the quotient Q of x is equal to 2x squared minus 3x minus 9. And the correct answer for this multiple choice item is C. In the next example, we are asked, what is the remainder? Notice the polynomial is x to the power of 101 minus x to the power of 90 plus 1 divided by x plus 1. In this case, it would not be appropriate to use synthetic division because you would have to list out 101 terms in the first row of synthetic division, which is not a practical thing to do. So in this case, in order to determine the remainder, remember that when you have a polynomial p of x, that p of a is equal to the remainder. X plus 1 is the same as x minus a negative 1. So in the form of x minus a, that tells us that a is equal to a negative 1 in this case. So if your polynomial p of x is of the form x to the power of 101 minus x to the power of 90 plus 1, we can evaluate p of negative 1 where you substitute in a negative 1 for x throughout the polynomial expression. So we have negative 1 raised to the power of 101 minus negative 1 raised to the power of 90 plus 1. At this point, I would like you to note something. Whenever you have a negative 1 raised to an even power, the answer will always equal a positive 1. When negative 1 is raised to an odd power, it will always equal a negative 1. It is important to notice this in order to answer to finish the question. So in this case then, p of a negative 1 will give us the remainder. So the remainder is going to equal a negative 1 raised to an odd power equals a negative 1 minus a negative 1 raised to an even power is a positive 1 plus 1. So your remainder in this case, negative 1 minus 1 is a negative 2. Negative 2 plus 1 is a negative 1. Your remainder in this case is equal to A at negative 1. So that's an example that forces us to use the remainder theorem. In another example, when this polynomial expression is divided by x minus 3, the remainder is equal to a negative 12. We're asked, what is the value of k? So once again, look at x minus 3, which is written of the form x minus a already. So the value of a here is equal to 3. What that's telling us is that when you evaluate p of a, the remainder is, p of a is equal to the remainder. So if your polynomial expression, p of x, is given by x cubed minus kx squared minus 11x plus 30, we need to evaluate p of 3. P of 3 is equal to 3 cubed minus k times 3 squared minus 11 times 3 plus 30. And we're told that the remainder is equal to a negative 12, which means that P of 3 is equal to a negative 12. 3 cubed is equal to 27. 3 squared is 9. multiplied by k would be 9k, minus 33 plus 30. So then we have a negative 12 is equal to a negative 9k, and then you have 27 minus 33 is a negative 6, plus 30 is a positive 24. So then we have a negative 12 minus 24 is equal to a negative 9k. A negative 36 equals a negative 9k, so that tells us that k is equal to 4. And the corresponding answer is D. In this example, it says, in which step does the first error occur when 2x cubed minus 4x squared plus 3x minus 6 is divided by x plus 3 using long division? So you have x plus 3 divided into 2x cubed minus 4x squared plus 3x minus 6. So the first thing we say is x multiplied by what is 2x cubed? And the answer is 2x squared. 2x squared needs to be multiplied by both terms in the divisor. So 2x squared times x is 2x cubed. 2x squared times 3 is a positive 6x squared. We subtract all of it, so it appears that everything is okay in step 1. When you subtract everything, 2x cubed minus 2x cubed is 0. A minus 4x squared minus 6x squared should equal a negative 10x squared. So the first mistake occurs right here. That value should have been a negative 4 minus 6x squared, a negative 4x squared and a negative 6x squared. It should have been a negative 10x squared. So the mistake occurs, or the first error occurs in step 2. That corresponds with B as your multiple choice answer. In example 5, which synthetic division is used to find the quotient when a negative x squared plus 7x cubed minus 4x plus 2 is divided by x plus 1? The first thing you should notice here is that the polynomial is not in descending powers of x. So let's rewrite the polynomial as 7x cubed minus x squared minus 4x plus 2 divided by x plus 1 is written as x minus a negative 1. So in the form of x minus a, that tells us that a is equal to a negative 1, which goes in front of the box using synthetic division. This eliminates C and D as multiple choice answers. The coefficients of your cubic term is 7. 7, negative 1, negative 4, and 2. It appears to us that B is the correct answer. Let's check it out. When you add the first column, it's 7. Multiplied by negative 1, it's a negative 7. The sum of the second column is a negative 8. Multiplied by negative 1 is a positive 8. The sum of the third column is 4. Multiplied by negative 1 is a negative 4, and the sum is a negative 2. So in this case here, the negative 2 represents your remainder, and the quotient would be given by 7x squared minus 8x plus 4. So the synthetic division used to find that quotient would be part B. Which statement is true when P of x equals x cubed minus 7x plus 10 is divided by x plus 1? In this case, I would set this up using synthetic division. In front of the box, I would record x plus 1 as x minus a negative 1, where a is equal to negative 1 again. So we have negative 1, and in terms of the polynomial itself, the coefficient of your cubic term is 1, but there is a missing quadratic term. So we put in 0 as the coefficient of your quadratic term, minus 7 as the coefficient of your linear term, and 10 as your constant term. Adding the first column, you get 1. Multiply that by -1 to get -1. Adding the second column, the sum is a -1. Multiplying that by -1, the product is a +1. Adding the third column, the sum is a -6. Multiplying that by -1, the product is a +6. When you add the last column, you get 16, which represents your remainder. In this case, you now have the polynomial p of x is equal to x cubed minus 7x plus 10. That can be written as p of x is equal to x plus 1, which is your divisor, multiplied by your quotient, and you add your remainder. Note that this polynomial can be factored a little further. So you have p of x is equal to x plus 1 multiplied by the factors of a -6 whose sum is a -1 with the x minus 3 multiplied by x plus 2, and then you add 16 at the end, which represents your remainder. So the statement that's true corresponds with C. In order for x plus 1 to be a factor of the polynomial p of x, the remainder would have had to equal 0. The remainder in this case is 16, which eliminates part B as a multiple choice, and similarly, p of a -1 equals 16, not 18, and that eliminates D as a multiple choice answer. So those are some multiple choice type questions. This is a potential long answer question that you could be asked about the remainder theorem. When the polynomial ax cubed plus 4x squared plus cx plus 3 is divided by x plus 1, the remainder is 2. That tells me in that statement that p of a -1 is equal to 2. In the second statement, when the polynomial is divided by x minus 3, the remainder is 222. So that tells me that p of 3 is equal to 222. Let's look at the first statement. When you evaluate p of a -1, you will get a times a -1 cubed plus 4 times -1 squared plus c times a -1 plus 3. And in that case, the remainder was equal to 2. So we have 2 is equal to a -1 cubed is a -1. So we have a -1a plus 4 minus c plus 3. What we're going to do now is set up a system of equations, it appears, to solve for a and c. So in the first case, we bring the a to the left-hand side plus c would equal 4 plus 3 and bring the 2 over. So we have a plus c, 7 minus 2 is 5. That's one equation that we will use as part of our system of equations. In the second case, the polynomial p of 3 would be given by, you simply substitute 3 for x in your polynomial. So it's a multiplied by 3 cubed plus 4 times 3 squared plus c times 3 plus 3. And the remainder, we are told, is 222. 3 cubed is 27, so we have 27a. 3 squared is 9 times 4, gives us a plus 36, plus 3c plus 3. There we have 222 minus 36 minus 3 will equal 27a plus 3c. So 222 minus 36 minus 3 is equal to 183, is equal to 27a plus 3c. That will be the second equation to make up our system of equations. Notice that when we're solving the system of equations using the elimination method, we can multiply the first equation by 3, and we can eliminate the c variable. So here we would have 27a plus 3c is equal to 183. When you multiply the first equation by 3, you get 3a plus 3c is equal to 15. Using the elimination method, we will take these two equations and subtract them. 27a minus 3a is 24a. Notice that 3c minus 3c is 0, and 183 minus 15 is equal to 168. 183 minus 15 is equal to 168. When you divide that by 24, the answer will equal a is equal to 7. That would be one of our solutions to this equation. To get the value of c, you simply choose one of your equations. A plus c equals 5. If a equals 7, we have 7 plus c is equal to 5. So c would equal 5 minus 7. C is equal to a negative 2. And that would be the final solution, the values of a and c that satisfy that system of equations. As a summary of the key ideas in this section, you can use long division to divide a polynomial by a binomial, and synthetic division is just simply an alternate form of long division. The result of the division of a polynomial in x, p of x, by a binomial of the form x minus a can be written as p of x divided by x minus a is equal to q of x plus r over x minus a. P of x represents the polynomial, x represents the divisor, q of x represents the quotient, and r represents the remainder. Or we can say that p of x is equal to x minus a multiplied by q of x plus the remainder r. To check the result of a division, you multiply the quotient, q of x, by the divisor, x minus a, and add the remainder to the product. The result should be the dividend, which is the polynomial p of x. The remainder theorem states that when a polynomial in x, p of x, is divided by a binomial binomial x minus a, the remainder is p of a. A non-zero remainder means that the binomial is not a factor of p of x. We will study more about the remainder equal to 0 when we study the factor theorem in the next section. If you have any questions related to the content of this presentation, please feel free to ask the question in the question forum, and I would be happy to answer it for you. Thank you.